In this problem, we have a CD with 6 tracks on it. We only like 2 of them. And we're going to find the probability of events when we listen to the first 2 songs in a random order. And for part A, it says, what's the probability that you like both of them? Now, pay attention that with this CD player, each song is played once in random order. So it's not going to repeat any of the songs until every song's been played once. So the probability of liking the first song and then also liking the second song, we're going to find by multiplication. The probability that, that's going slow, that we like the first one multiplied by the probability we like the second one if we're given that we like the first one, if we know that that event already happened. So this is conditional probability, and let's look at this with the numbers. What's the probability we like the first song? 2 out of the 6 we like. So a 2/6 chance, reduce that, it's 1/3. What's the probability we like the second one? So here's the conditional probability. Because that first song has already been played, the conditions have changed. So for the probability of liking the second now, there's just 1 remaining song that we like, and there's just 5 songs in total left. So the probability of liking the second is 1/5. So that's the probability of liking the second after that first song we like has already been played. So to find the probability of liking both, you would multiply those 2 together, and when you convert that to a decimal, you get this answer. We're going to say an event's unusual if it has a less than 5% chance. This is 6.7%, so it's barely above the unusual line. So we'll say, no, it's not unusual for us to like both of them. The probability we like neither would be very similar. We don't like the first times the probability we don't like the second, given that we didn't like the first. So not liking the first, there are 4 we don't like out of the 6. 4 out of 6 reduces to 2/3. Now for the second song, here's our conditional probability. There's only 3 songs we don't like that haven't been played yet, and there's only 5 songs total that haven't been played. So 3/5. Multiply those 2 probabilities together, convert it to a decimal, you get 0.4. For part C, the probability that you like exactly one of them, this is really a key thing to think about. If you listen to 2 songs, there's only 3 options. You like them both, you don't like either one of them, or you like exactly one of them. So the probability of those 3 things have to add up to 100% because you have to fall into one of those 3 categories. So if those 3 things add up to 100%, with a little algebra, we take 1 for 100% and minus the 2 probabilities we just calculated, and we'll find the one probability we haven't calculated yet. So 1 minus those 2 results, and that's the probability you like exactly 1. And then D says to redo the 3 problems we did, but now a song can be replayed before all 6 songs are played. So now it's really totally random. There's no rule that every song has to be heard once before a repeat. So the probability of liking them both is probability of liking the first one and probability of liking the second. There's no conditional probability here because every song is an option again for the second song because repeats are allowed. So the probability you like the first one is 2 out of 6 or 1/3. And now when the second song comes around again, it's still 2 out of 6 because any song can be played. So it's 1/3 times 1/3. And I'm not going to do the rest of part D here. It's very similar to what we just went through in A through C. So I'll leave that for you to finish.